Hi, I'm Nick. I'm here with First Updates Now for Behind the Bumpers interview with Team 1466. Webb Robotics is here from Knoxville, Tennessee. I've got James and Colby. We're going to talk about our intake and our really cool vision with our arm and how this team has been absolutely tearing it up at Magnolia. So stick around for this Behind the Bumpers interview.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the Join button in any YouTube video to pledge your support.
All right, Colby, so let's walk through the intake. How are you guys picking up notes in Crescendo?
We have a very compact under the bumper intake in the back. We're using polycarbonate rollers with silicone tubing over the middle 14 inches. We're using 3D printed guides on the sides to bring the notes to the middle, and it's worked very well for us.
And did you guys use anything else before those silicone tubes, or did you just try the silicone tubes
So
first?
we prototyped in the beginning of the season with compliant wheels and a much narrower intake, and we found that this worked so much better, and that's why we stuck with this.
Awesome. And now, once the note is off of the floor, it goes into the arm. What's going on with the arm, and how are you guys shooting amp and speaker?
So on our arm here, we have this large shooter mechanism with indexing rollers and shooter rollers. So when the note comes into our robot, it goes up using these indexing rollers until it hits our IR beam brake here, and then it stops. And then we wait till we're ready to shoot.
And this shoots both speaker and amp, right?
It does.
Okay.
So in this orientation, we can shoot speaker, and we also can move our arm to shoot different layers of speaker, but our arm can also move all the way up to shoot amp as well.
Right. And before we move on to some of the code, how is the drivetrain working for you guys this year?
So we're using SDS MK4i swerve modules powered by Krakens and L2 gearing. And it's worked very well for us as well.
Awesome. So back here in the back of your pit, you've got some really awesome boards. So what kind of process are these boards showing off? Because they're really well done.
So these boards here show the progression of our climbing hooks in all of the iterations we went through. We started with this wooden one here that we laser cut in-house, and all of these other wooden ones are also laser cut. These are polycarbonate ones that we prototyped as well. We started with circles on both sides, and then we found that we wanted it to be straighter so we could have a larger reach on the chain.
Okay.
And then eventually we progressed all the way down to our final design here.
And how successful has that climb been for you guys?
The climb has been our most successful part of our robot by far. It climbs very fast in less than 2 seconds.
That's awesome. Alliances can rely on you because you can do that climb so consistently. And that keeps your motor count down too. You're not using a separate elevator.
Exactly. That saves us 2 whole motors for climbing.
Okay, awesome. Well, let's pass it on to James. So I've heard you guys have made some improvements in the code throughout this competition from SMR, and then using the arm, shooting, vision, just a lot to cover here with the code side of things. So how are you guys moving this arm to shoot from near the podium and around the speaker?
Sure. So we've got 2 Falcon motors hooked up right here, and they're moving the arm on these large sprockets, and we're actually tracking the position of the arm. We're using a large through-bore encoder that goes through this hex shaft that runs all the way across on the arm. And so we're tracking that position and using that position to base where the arm should be. Using that information of where we want the arm to be versus where it is, we're using a process called PID tuning, which allows for precise incrementation of the arm to put it in the position we exactly want it to be. And so we're using that. We have a precise position for the amp, and so it goes straight up to here. And we're using PID tuning to get up right up there. And then we're also using it to slowly level our arm down and then rest it here.
Right. And that's all using the April tags on the field?
No, actually. So what we have a camera running a photon vision library, and we're actually using the April tags for dynamic shooting position. So based on the absolute position from either the blue or the red speaker, based on which alliance we're on, we're calculating using a logarithmic function. We're calculating how the angle of the arm based on how far away we are. So we're just plugging the distance in and we're calculating a distance, which is really cool.
Awesome. All right. Well, can I see this robot in action? Maybe like a note through the arm, see the arm kind of move up and down to show off all the aspects of this amazing robot.
So this is on the intake. And then we also have a amp position, which is right here. So what it does is it stays at this amp position, it shoots it out, and then goes back down.
Okay.
So that's the PID tuning in action.
And can you just keep that arm in the amp position real quick?
Sure.
And so you can see the hooks here, and then what are these larger hooks for?
So these larger hooks help hold our chain in after the robot disables. We had problems with the robot falling back down after we climbed, only when we had these. So we added these in, and it transfers the weight of the robot from those hooks to these hooks after our robot disables.
Okay, that makes sense. And that keeps it steady. And some iterations you got going there?
Yeah, so we started looking at with like a carabiner hook design, and then we iterated with these slide designs so we could find the right geometry that we wanted. And then we made a prototype here that we actually tested climbing, which it broke, which means it worked.
Yeah.
So then we made our final design right here. That's on the robot now.
That's absolutely amazing. And any improvements you have looking into RCR and week 6?
Yeah, so we're looking at switching to 3-inch shooting wheels rather than 2-inch self wheels, and that will help us shoot further and more powerful. We're also looking at improving our vision to work even better than it has now.
Okay. And any specific auto improvements that you're looking at before your competition?
So I think for auto, we're planning on looking at a 5 or 6 piece auto for SMR, hopefully.
Okay.
If all goes well, we'll be using vision to dynamically shoot during auto. And so that should be, that's one of our big checklist goals for SMR right now.
Okay, amazing. And one last question. You guys have a special name for your robot. You've got these amazing party bumpers, but...
Yeah, so this robot's actually named Toothless, which is based around this design. The shooter mechanism is, we noticed, looks a lot like a dragon. And we tried to come up with various dragon-esque names, and we finally settled on Toothless because it has the cute, fun feel, but it's still a good robot name. And we've actually even named all our batteries after different characters from How to Train Your Dragon.
Absolutely amazing. Well, thank you guys so much for your time. This is an incredible bot, and absolute best of luck at the Rocket City Regional in week 6.
This video on fun is brought to you by viewers like you and also in partnership with the following. AndyMark is your one-stop shop for all your robotics competition needs. Celebrating 20 years of quality robotics parts and superior service, AndyMark employees have over 200 years of first-team experience. From mechanical and electrical products to tools and hardware, head on over to andymark.com for high-quality and affordable solutions.